The basic science behind scanning electron microscopy is pretty simple. It's been around for more than 50 years. It's a way of beating the diffraction limit of light. So any item smaller than half the wavelength of light is too small to see with a light microscope. Electrons have a much shorter wavelength, so we're able to image structures that are a lot smaller than the diffraction limit of light in order to see what's going on at that scale. At the top of the column, in this section right here, is an electron gun. As I mentioned, this is a field emission scanning electron microscope. So the electron gun is essentially a tungsten filament, a very sharp filament. We use a strong electronic field to draw a current off of that filament, and that creates the beam, the probe beam that you use to impinge on the sample and image the sample. Below the electron gun, there are condenser lenses, scanning coils for moving the beam, stigmators for adjusting the roundness of the beam, and ultimately there's a probe lens at the bottom, down at about this level. When the probe, the electron beam, exits from the probe lenses, it then enters the chamber, which is the square section here, and it impacts the sample, where the sample absorbs the energy of those electrons and then re-emits new signals that we use to image the sample. You'll also find inside of the table there's a turbo pump that actually helps pump the chamber down to high vacuum. The chamber pressure is on the order of 10 to the minus 5 millibar. There are two different pumps used to pump the chamber down to that level. The main pump is located in the adjacent closet that you don't see, and then the turbo pump is in this table here. The sample preparation happens in this area here. Because we're putting a sample into a high vacuum environment, 10 to the minus 5 millibar, a lot of things that exist in the normal environment as liquids or solids can be vaporized. So we want to keep the sample as clean as possible, which includes keeping our finger oils off of it and also any condensation from the air. So this is ultra high purity nitrogen gas, and it's fitted with a gas gun. So what I'm going to do is use a stream of nitrogen from this gas gun to just remove any loose debris from the surface of the sample before we image it. So we've waited long enough for the pressure to equalize in the chamber, and I'm just going to open the door, again by pulling on this handle, and open it gently until it reaches the stop position. I'm going to put the pin into the hole in the stage, and then there's a set screw on the side of this that I can tighten just with my fingers. So once it reads vacuum OK, I can start the beam by clicking on this 5 kV button in the beam submenu. When I do that, you hear the column valve open. That means the upper column is open to the chamber and the beam is coming through to hit the sample. The picture that we get initially is going to be pretty bad. So there are a number of things that we can do to improve this.